Hello guys, welcome back to our channel You Are Learning. In this video we are going to discuss about minimum cost spanning tree, which comes under greedy method approach. So previously we have already discussed about knapsack problem in greedy method. Now let's discuss minimum cost spanning tree. So generally minimum cost spanning tree is of two types, Prim's algorithm and Kruskal algorithm. First, the Prim's algorithm. So both the algorithms are same, but the only difference is in problem solving. So let's see it firstly. So Prim's algorithm, it is a greedy method approach. It refers to construct the minimum cost spanning tree. So here a graph is given through which we have to construct a minimum cost spanning tree. So all there are three rules guys, so we have to satisfy these three properties. It should contain all the vertices of a graph. If a graph has n vertices, then the spanning tree must have n minus 1 edges, so it should not have any cycle, so it should not form any cycle. So I getting, for a given graph we have to calculate the minimum cost spanning tree. In that process we have to satisfy these three conditions. So the three conditions are, it should contains all the vertices of a graph. The graph which we are considering, from that graph we have to take all the vertices. We have to connect all the vertices without forming any cycle. For n vertices, n minus edges should be there and no cycle should be formed there. So this is what the rules of Prim's algorithm. So here, so this is an example guys. So here in this given example, first we have to see the paths guys. This is undirected graph, are you getting? So this is undirected graph. So from here, firstly we will take the source node, which is starting node a. So from a, the joining vertices are, we will see the joining vertices along with their weights. So from a we are having a to b and a to c. So from a to b is 7, a to c is 3. So in these two, minimum value is 3, so which is a to c. So first we will join a to c here guys, are you getting? Firstly we will join a to c here. Next, in second step, what we do, already we have a to b of cos 7, which will be continued. So first here we will write here a to b equals to 7, and next from c, as a is going to c, so now we will see a c to the joining vertices. So c to d and c to b. So c to d will be 10 and c to b will be 4. In these three, the minimum value is 4. We will consider three of the values and we will only take the minimum weight value. So here the minimum weight is 4, which comprises of c to b. Now we will join a to c and c to b guys. In the next step, similarly we will join, now the left elements are a to b and b to d. From here the left elements are a to b equals to 7 and c to d equals to 10, which will be continued here. A to b equals to 7 and c to d equals to 10. Now in the previous node we have gone to b rise, right? So now we will see from b to e, b to d. B to e, d is 9, b to e is 11. So b to d is 9, b to is 7, 11. So what we will do now, we will check from these all four, the minimum value is 7. But if you consider that it will form a cycle, so we does not consider here a to b guys, which will be not considered. C to d is also not considered guys, because of highest value. So after 7 is eliminating, the lowest value here is b to d, which is 9. So now we will join b to d here, are you getting? So b to d is joined. In the next step, what is left over? These two elements. So in these two, 10 is the smallest element, but if 10 is possible, c to d is not possible guys, because it forms a cycle, are you getting? So it will also not consider. So only element left is b to e. so b2 is considered. So here we contain all the nodes, I mean vertices a c b d e. We are having all the nodes and vertices, and for here what are the rules? It should contains all the vertices of a graph. So the graph vertices are a b c d e. So we are having here a b c d e. Okay, satisfied. Next, it should contain n vertices and n minus edges. N vertices, so n vertices means a c b d e, and n minus 1 edges, like 5 vertices, so 4 edges, 1 2 3 4. This rule also satisfied. Next, it should not form any cycle. So here no cycle is formed, guys. So this is the required output of Prim's algorithm. So thanks for watching. I'll see you in the next one.